Hello, everyone, and hello to my session where I will show you how to easily generate Helm charts for your Java application. My name is Marc Nuri. I work as a software engineer for Red Hat, and I'm currently focused on the Fabricate Kubernetes client and on Eclipse JKube, which I will be showing today. I will be around the next couple of days, so if you have any questions regarding these projects or what we see in our talk today, I will be really glad to help you. I'm also the author of Full Stack Quarkus and React, so if you are interested in this topic, I invite you to check it out. This is the agenda for today. I will start by clarifying the concepts of inner and outer loop, which I think will come in handy when explaining JKube features, especially those related to Helm. Then I describe a little bit what are the challenges that developers might face when they are deploying their applications to Kubernetes. I will continue with giving a short introduction to Eclipse JKube and how it can help you overcome some of these challenges. And then I will showcase a project or a popular Java project and how you can generate Helm charts for that application. And also, I will show you a suitable configuration, both for the inner and outer loops, that you can replicate in your projects. And finally, we will have some time for Q&A. And also, in any case, if you have any questions during my talk, I invite you to ask them immediately. OK, so let's start by clarifying the concept of inner and outer loop to better understand what are JKube's features. So we talk about the inner loop. It's that cycle that the application developer follows since he or she starts coding the application until those changes are shared with anyone. So it usually involves coding the application, building the application, deploying it to a development environment, making sure that everything works, maybe some debugging, and so on. However, what we want here for this loop is to make it as short as possible. We want for the developer to have immediate feedback so that he or she can continue to keep adding value to the application, contributing new features. On the other hand, the outer loop is the cycle that that the application or the code suffers once the application, once the developer has shared the changes with the rest of the team. So it usually happens once the code is committed and pushed to the version control system. This cycle usually involves building the application, deploying it to a testing environment, passing automated tests, compliance and security auditing, and maybe, in the end, deploying it to a production environment. So what we want for this cycle is to make it as automated as possible. We don't want any human intervention here, especially if we are following this continuous deployment philosophy. We want everything to be as automated as possible. So the inner loop, we wanted to make it short, and the outer loop, we want to make it automated. The problem is that when we are dealing with Kubernetes and the cloud in general, both these loops need additional steps, and they also require additional expertise from the developer and tooling and configuration files and so on. So everything becomes a little bit more complicated. So yeah, as I said, when deploying your applications to Kubernetes, you start to face some additional challenges. The first one is that you need to package your application as a container image. So container images are the way you usually distribute your applications for Kubernetes. And here we can see a very simple Docker file to containerize a Java application. So in this case, it's kind of simple, 6 lines, or 6 or 7 lines. But these files tend to grow as the application grows in complexity and so on. So they require tooling, they require maintenance, they require an expertise from the developer to maintain them, and so on. In addition, in the bottom, you see like the typical commands that you would run to containerize the application, like docker build, and then to push it to external registry. So in addition, you will need additional tooling and stuff in your laptop or in your environment. The next challenge is creating the cluster configuration manifests, so those ugly YAML files. Here we have a very simple deployment for an application, but we already have like 4 files: the deployment, then the service to expose the deployment to the cluster, and then a config map and a secret to hold the application's configuration. So again, we need to maintain these files, and we need to be knowledgeable of the special syntax that these files contain. In addition, here we see the command to apply these files to our cluster. And finally, we come to the Helm charts. The Helm charts are no more than those cluster configuration manifests that are now used as templates. So the templates contain some placeholders that you can replace whenever you install into a given environment to customize it for that given deployment. In addition to the YAML files that now we call templates, we have the chart configuration, the chart YAML, and then the values file, which contains the default values in case we don't provide any of them. Again, we also have to use additional tooling, like in this case, the Helm create or the Helm push to push it to a Helm chart registry. So yeah, if we see it, developing applications for the cloud becomes something really complicated, and developers need to focus on other tasks instead of keep adding value to the application, right? So the application developer should be focused on the application stuff and not on the platform and other things. So given this environment, it would be great to have some tools that would help us out in our day-to-day jobs when dealing with Kubernetes. So let's get to know better JKube and how it can help us with these tasks. So JKube is a set of tools and plugins that will allow us to generate container images and to generate and deploy the cluster configuration manifests. So basically, it abstracts away the implementation details when we are dealing with Docker files and with those cluster configurations, the YAML files, and automates most of the tasks for us. It consists of several components. The main module, which is JKube Kit, it's a standalone module that you can use yourself. However, JKube also has the Kubernetes and OpenShift Maven and Gradle plugins that can be used to seamlessly integrate JKube in your project. So if we continue with this Popeye theme, JKube is effectively this kind of spinach that will help you or give you superpowers when dealing with Kubernetes. I really like to use this diagram when explaining JKube's features because it shows how it integrates with your current development workflow. So up until now, usually you would code the application and then package it as a jar or a WAR file, and then you would you might be required to deploy this to OpenShift or to Kubernetes, and you'll probably feel maybe overwhelmed, or I don't know, you don't know how to continue. So here's when JKube can help you out. These are some of the Maven, Kubernetes Maven goals. So for example, KTS build will allow you to generate the container image. KTS push will allow you to push that image to a container registry. The KTS resource will allow you to generate the YAML files. Apply will allow you to apply those YAML files to the configured cluster. Helm generate the Helm charts. We will see that later, and so on. And in addition to all of these goals, we also have some stuff that will help you in the development phase or in the inner loop, like log, which will allow you to print the logs of the application running in the cluster, debug, to live debug the application that's running as a container, and remote dev, which is a really cool feature that will allow you to live code the application which is running in the cluster, and you will, if you come to our demo session tomorrow, you will be able to see it live. And yeah, well, this table shows how some of these features would apply to the inner and outer loop, but I really don't want to spend much time on this, so I think it's better if we see it in action. So for today's demo, I'm going to use the Spring Pet Clinic. So this is a fork of the project. I'm pretty sure that if you are a Java developer, you know the Spring Pet Clinic. If not, this is like a project that Spring has to showcase some of its features. So I like this project because it's a little bit more complex than the typical Hello World. It's not too complex, but anyway, it's a little bit better than that. So I have this fork here. Right now it's up to date. So it's the same as you would have if you clone the project. And I have set it up here in my IDE. So for deploying this, let's say that I'm working in the inner loop. I'm going to use the developer sandbox that's provided by Red Hat for free. So it's a convenient way to have a free cluster to get to know or to learn Kubernetes and OpenShift. So I already have my cluster here, and I already connected to it on my machine. It's empty right now. And the first thing I want to show you is how easy it would be to deploy the Spring Pet Clinic to Kubernetes without just by adding the JKube plugins. So in this case, I'm going to add the OpenShift Maven plugin and deploy the application. OK, so that's it. That's all the configuration I'm going to add here. And now I'm just going to run the typical goals. So package. I'm going to package the application. Then I'm going to build the tests. Build the cluster configuration manifests. Build the container image. And apply that image to my cluster. So now it's compiling, packaging. The first, here we are running the resource goal. So what JKube did here was infer that this was a Spring project, and it generated some cluster configuration manifests that are suitable for this project. Then we're running the OC build command, which again now detected that this was a Spring project, so it's building an image that's suitable for my Spring application. And it also detected that I configured an OpenShift cluster, and it's running an S2I build in this case, which will run the container image build inside the cluster. So I don't need to have anything in my laptop to be able to build this container image, for example. So the network here is not great, and this will take a while. In the meantime, I just want to show you the let me see. Not sure why it's not showing this stuff. OK, so we should see here the I'm not sure why it's not showing them. For some reason, it's not loading the not locating the generated files. I'm not sure why. So yeah. Yeah. Yes. So yeah, if basically, so in this case, for example, this is the Red Hat Developer Sandbox. So basically, okay. That's it. That's the extra thing that I did that you didn't see. But yeah, so for some reason, I'm not getting here the target directory. I don't know if anyone knows why. OK, so yeah, if not. I don't know. It's not working great today. This. OK, so this is the files that generated that JKube generated for us automatically. In this case, now it's showing. OK. Cool. So the first thing is a deployment. So we detected that this was an OpenShift cluster, so it generated OpenShift-specific cluster manifests. So in this case, a deployment config to hold the configuration for the pod templates and so on. It added some annotations, it added some labels, a default number of replicas, and then since it detected that this project has the Spring Boot actuator, it added some readiness and liveness probe. So just to show that JKube is kind of smart and detects what you will probably be needing. Okay, then it generated a route and a service. So a route is like an ingress for OpenShift. And if we check the cluster, the application was deployed, and it should be available, right? So we just added the OpenShift Maven plugin, and we were able to quickly deploy the application into OpenShift without having any kind of knowledge of either OpenShift, Kubernetes, or even Docker, right? We didn't need to figure that out by ourselves. So yeah, the purpose of this talk is to show how to generate the Helm charts. So this back. Okay.
And if instead of OC deploy, you have like a Kubernetes deploy, is it?
Yeah, that's what I'm trying to show now, but this is not working. Not sure why.
So are the other platforms supported as OpenShift as well? Like
Yeah.
Rancher, for example, or something?
Rancher is more, well, yeah, Rancher is Kubernetes, so it should. OK, so let me try to continue. OK. So in this case, we saw how that would apply for the inner loop, which was just, OK, I have my Java application. I want to deploy it to a development environment. In this case, was OpenShift. But what we want now is to focus on the outer loop. This means I want to distribute my application for other production environments. OK? So yeah, what I did some minor changes to the Spring Pet Clinic. I basically added another resource bundle for the messages. So before we saw a message that said welcome. I'm not sure if I have it here. Yeah, I closed it. But when you enter this Pet Clinic, you saw welcome. Now we are going to see welcome to our store. OK? And this is all that I've added. As I told you before, JKube automatically generates stuff for you, but you can configure this stuff or override some of these defaults that JKube assumes for you. And one of the ways that JKube does this is by providing fragments. So we are going to provide YAML, but only a little bit part. We don't need to know the full syntax of a given resource in order to override it. So for example, in this case, let's say that I want to customize the annotations for the deployment, or the number of replicas. Or in this case, I want to customize the resource bundle that will be used to show the messages to the user. In other cases, especially for the outer loop, we might want to configure the database connection, or I don't know, anything you can imagine. So with fragments, we can either provide this via some hard-coded value, so like this, and it will merge it with whatever JKube generates, or with these placeholders. And these placeholders will work differently depending on which loop we are. So if we are in the inner development loop, we will provide this stuff as Maven properties. If we are in the outer development loop, we will provide this as Helm chart parameters. Okay. So I have another fragment for the ingress, and I want to customize the host. And I finally have another fragment with the Helm chart default values. So this will also be merged with whatever JKube generates for us. OK, so if we go to the inner loop, what I did for this project was add two profiles. Let me find them. OK, so I created a dev profile, that this would be the one for the development loop, same say inner development loop, what we saw before. And it's active by default, so we don't need to activate it. And what we're telling here, JKube, is, hey, the deployment annotations, I don't want to use anything. Just use the ones that you are going to generate for me. For replicas, use one replica. For the messages, use this value. And for the ingress host, use this other value. So if now Sorry?
So the fragment files are only for the inner loop or also for the outer?
Which files? The fragments would work for both. That's important. That's important. So yeah.
With the fragments, you only override your specific behavior. So your property, like a property file.
Yeah. Imagine that you want.
Same like Marcus, if you say I want to use another port.
Yeah.
Okay, and everything else is like default.
Exactly. So
Thank you.
now you will see it. So if I manage, okay, if I manage to make it work. Okay. Hopefully I can now open this. So yeah. No, not yet. Okay, still not working great. I don't know what's going on here, but okay. Yeah, okay. Yeah. So as you can see now, the deployment contains annotations. We said that we want to use the ones that JKube chose for us. Replicas one. It added this environment variable that we didn't have before. And I can't remember what else we had here. Yeah. So basically, here it override this. For the ingress, we had these placeholders here with the host and the port and so on. And for the ingress, it used the one that I provided in the property. So this one, and so on, right? So this would be the inner loop. I could now do the same as I did before. I would apply these resources to my cluster, and they should work. I'm not going to do it because we are running out of time. And yeah, but now what we want is to distribute our application for production, right? So we want to generate the container image and push it to a container registry, and to generate the Helm charts and also push them somewhere. So for this purpose, I'm going to use GitHub packages. So yeah, they live in the same repository as the other stuff. And it's quite convenient. So for the generator part, what I want to configure here is the name of the generated container image. Okay, because this is a special requirement from GitHub. In this case, it has to have this image. So if I'm going to run this now, I will select the production, and then KTest build and KTest push. So the first one will build the container image, and the second one will push it to the image container image registry. Okay, I want to highlight that I don't have. So in this case, the image is being built in my machine, not in the cluster. And I could use either Docker, because I have a Docker daemon here, or Jeep, or something else. And JKube will allow me to customize this. So the container image was built, and it should have been pushed to the first. OK, it's not showing up. It's not showing up well, but anyway, you need to trust me. The image, the image was pushed there. And now let's focus on the Helm part, which is the important part here. Okay. Yeah. So in this case, we are not using the OpenShift Maven plugin because we want to build vanilla Kubernetes resources. So before we were using deployment config and routes and so on. Now we want to use a deployment or an ingress and so on. So we want to use the default Maven plugin. For the chart configuration, I need to specify the chart name, so I can do it this way. This must match my package name here. And then I'm going to provide certain parameters to replace the values that I provided here as placeholders. Okay, so this will be part of my generated chart values. So for the resource bundle that we said before, I want to overwrite this environment variable and provide this value by default. So the easiest way is to provide a value here, and this will be merged into my chart values. We will see it later. For deployment replicas, instead, I'm going to use a Helm expression because, well, I want to showcase the features of JKube. So in this case, I'm going to use a Helm expression. So in this case, it will be using deployment.replicas, which are part of this other fragment. Or I can even use an even more complicated Helm expression. So for the annotations, I want to merge the values provided here and here. And for the host, just like with the replicas or with the base name, I'm going to provide this value. Okay? So if and the last part of the configuration shows the repository where we want to push this Helm chart. So in this case, I'm going to use the GitHub container registry, or I don't know what it's called, GitHub container image registry. And I'm going to use OCI as the type of chart. So JKube supports multiple ways of publishing your Helm charts. In this case, I'm going to use OCI. The credentials for this are set in my settings XML. So if I go to my M2 directory and I open my settings XML, you will see my credentials there. There are many other ways to provide these credentials, but in this case, for this scenario, I'm going to use this. I don't know if I said this before, but when I run this command or the commands that I'm going to run now, I'm running them in my local machine, but as we saw in the outer loop definition, this should be run in a CI environment, right? We want to make this automated. This shouldn't be run by me. So yeah, just like before, I'm going to generate the resource files, which will be the input for the Helm files, and then push the chart to my Helm repository. OK, so the Helm chart was created, and now it's being pushed. We can see, I mean, although this is transparent for users, we can see here the generated Helm chart. So for example, what we're talking about, the deployment, it used the expression that I provided in the POM XML. For the Spring-based messages, it computed this value. We still have those liveness and readiness probes that JKube generates for us. And for the replicas, again, it generates this expression for us. For the ingress, it's something similar. So the host comes from here. And what JKube did was generate the chart YAML file with some settings that it inferred from the POM XML configuration. You could overwrite most of this. And a merged version of the chart values files, which would be part of the fragment that we provided here and part of what it generates from the configuration we passed in the POM XML. And here, it should show that we pushed this like 1 minute ago. I don't know what happened for the container image part. So now, OK. I forgot to deploy the previous. Yeah, I'm going to use the same cluster I used before. Because I don't have any other one. But the idea would be that you would be deploying this to a production cluster. OK. So here, we can now use the Helm tool to install the chart. And now it installed the same application, but using Helm instead. So this is what your operations team might be using at that point. Again, we have the actuator, so the readiness probe needs to pass, and in a moment, this should be marked as ready. We have the 2 replicas that we set by default. So now if we open this, OK, it shows the message from the production resource bundle, and it's using the URL that I provided as default. Okay? We can uninstall, for example. The chart should be uninstalled. And let's say that in a given environment, we want to overwrite the host. So in this case, I want to use a different host. It's as simple as overriding the default value. And now when I open the URL, instead of using that prod, whatever it was, the default value, which is here, instead of using this, it will be using the one that I override in the command line. So, yeah, different. Okay, so, I mean, despite the hiccups, we were able to generate the Helm charts and work in 2 different ways with a project that was recently just cloned from GitHub, and it's a pretty common project. Yeah, so I don't know if you have any questions or anything. Yeah.
The Helm chart, so they won't be versioning of the source code. They are used by the CI in the outer loop, right? They are generated by so the goal is that. So the developer will never see dash Helm chart.
No. I mean, because I run the Helm command line?
Yeah, I mean, no, even because you have actually generated and you have in your laptop, because you have in your, so in your JKube directory, but the developer will never see.
No, that should be transparent for the developer. That's the main goal. I said I'm going to show this, but the developer shouldn't even be knowledgeable of it.
Is there, because at some point you're never going to publish anywhere the Helm chart, so even if like...
Yeah, you should publish to a Helm chart registry.
Okay, you
Public, this is, so this is what we are doing.
Yeah, that's true.
This part here. This might be a private registry or a public registry, but the goal is to publish it there. So the CI environment will generate the Helm chart and then push it here.
Okay, and then there will be another job that update the application.
Yeah, that's not part of this. We are really working on adding more Helm features to JKube. So one of the other goals in the midterm is to be able to provide your own Helm. So here we are seeing like JKube is generating everything for you, and then everything is suitable for, depending on how you configure stuff, for either the inner loop or the outer loop. The next iteration would be to be able to provide your own Helm charts, because for whatever reason, and then use our tooling to be able to push it to a registry or maybe install it or all of that stuff. So yeah, we're working on adding more features. Yeah, I'm not sure if there are any other questions. Yep.
The integration for Quarkus, so does it work with Quarkus as well?
It works with Quarkus. So yeah, Quarkus has its own, in the Quarkiverse there is the Quarkus Helm extension. So you can use that, or depending, you can also use, so for example, Quarkus has its own extension for everything. You can use it to build container images, to create the cluster configuration manifests, to create the Helm charts, for everything. However, maybe in your company or in your team, you are managing different projects like Spring, Micronaut, Quarkus, whatever. If you are using a different approach for each project, then it can become messy. So the idea of JKube is, hey, you can use Quarkus, but you can also use our approach here. And the Quarkus extension was based on what I showed you here. It now has some more features, which are more specific to Quarkus. So for example, you can configure stuff in the application properties. But other than that, it's essentially what you saw here. So my recommendation is, hey, are you using just Quarkus? Use the Quarkus extensions. They are meant for that. If you are using, or if your team is handling different projects, then probably you're better suited using JKube or something else. Yep.
So if I have a project basically which has already a Helm chart and all this set up, is there an easy way to basically migrate this, or so I don't have to specify all the configurations from
Well, it depends. So maybe you can use our approach, clone this project, see if the configuration would work for you. Maybe not. If it's really complex, probably not. Then you're stuck with that. You would need to either start this from scratch, which might not be suitable, or what I was talking before. We've seen cases like yours, so you have your Helm chart, you have your stuff, but maybe you want to use the tooling for I don't know, for management or whatever. We will be trying to support that use case in the near future. Okay, so yeah, I don't know if you can leave my if I get your contact, I can reach out to you and see what your specific use case is, and maybe we can actually tailor it a little bit more for that kind of scenario. Cool. Any other question? Okay, so thank you very much for coming.